Hello everyone. In this video we will learn how to recreate realistic geometries in COMSOL Multiphysics. Besides this, we will learn how to draw a 2D sketches of objects and how to create objects from 2D sketches. Techniques for recreating realistic geometries in COMSOL Multiphysics will be explained on the following example. So what you can see over here is a 3D CAD model of a mount system used to support mirrors in optical systems. This is the back view of the mount system, and the system with the mirror attached to it looks like this. This is the mount, and this is the mirror with the back structure. You can see these clamps here that are used to support the mirror. Let us first explain why do we need to recreate realistic geometries in COMSOL Multiphysics. Well, it is true that we can download CAD files from manufacturers, or we can use some software to model these CAD files. However, these CAD files are often not suitable for simulating multiphysics phenomena in COMSOL Multiphysics. To illustrate this particular example is downloaded from the manufacturer website. So the Newport is a company that produce support and mounting systems for mirrors and lenses. This is a realistic CAD model with all the details, with screws, with these side clamps, with holes, and even with the logo, with the company logo. Well, if you import such a geometry in COMSOL Multiphysics, and if you mesh such geometry, you will obtain something like this. Look at this. So you see over here the mesh density that basically corresponds to the logo. So COMSOL doesn't know that this is a logo, and COMSOL will mesh this, will completely mesh this, and then you, instead of having probably 10,000 degrees of freedom or maybe 50,000 mesh elements, you will have several millions of mesh elements. And if you define certain boundary conditions, for example, in this case, you want to simulate how the system will behave when you apply heat to the system, or if you basically want to see how the mirror will deform once these clamping forces are being applied to the mirror surface, you will not be able to simulate this in COMSOL Multiphysics. Moreover, you will have problems to define the regions, because this is an assembly designed in Pro Engineer or CATIA or Fusion 360 or SolidWorks. However, when you import this geometry in COMSOL Multiphysics, everything will be merged. So COMSOL will not be able to properly recognize the domain, the edges, etc. that are necessary for defining the boundary conditions. Furthermore, while meshing this geometry, you will notice that COMSOL will produce some warnings and even some errors. Basically, what will happen is that certain edges here are too narrow, such that COMSOL is not able to properly mesh them. For all these reasons that I explained, you will have to recreate the geometry. And moreover, you will need to simplify the geometry by eliminating some details that are not relevant for your simulations. Because all these curved surfaces, for example, curved surfaces that look like this, or some irregular shapes, or small narrow surfaces, will increase the number of mesh elements, because the adaptive mesh refinement will produce very dense meshes in certain regions, especially in these edges that are irrelevant. So you will also need to simplify the geometry. That is, we need to recreate the geometry. And this looks like a difficult task taking into account the complexity of this geometry. However, in this video, I will show you a very convenient technique for quickly reproducing this geometry. So our technique for reproducing the geometry is to reproduce the geometry layer by layer. So what we are going to do, we are going to define cross sections. So we are going to slice this complex geometry in several cross sections, and then we are going to extrude the geometry, the 3D geometry from these sliced cross sections. And this is a very convenient, a very efficient technique for reproducing such geometry. Let us start from the very beginning. So what I'm going to do right now, I'm going to open a new COMSOL window and I'm going to import a realistic 3D geometry. How to do that? You click on Model Wizard, you click on 3D, and in my case I'm going to deal with the structural mechanics module and I'm going to click on solid mechanics. I click on Add. And I click on Study. For Study, I choose Time Dependent and I click on Done. However, you can choose any study that you would like. So I'm going now to import the geometry from a file, from a SAT file, and I'm going to give you a link in the description below to this file that can be downloaded from the manufacturer website. So I click on Geometry, I do right click, and here you have several options. You can click on Import, and then you click on Browse. So in my case, I'm going to import the geometry that's basically being defined in a CAD file. There are different files that can be used, and from my experience, I can tell that SAT files are the best for importing the geometry. Actually, I have made a video that explains how to import 3D geometry in COMSOL Multiphysics from, let's say, Fusion 360 or from any other software that you use to define the geometry. This is kind of a tricky job. It's not easy to figure it out, but once you figure it out what is the best format, you can easily import the geometry, as you can see over here. I click on Open. Here it is. And I can simply click on Import. And it's going to take some time to import it, but we will soon see our geometry, our realistic geometry of the mirror mount. Still working. Okay, almost there. Let's see now. Here it is. So this is a realistic geometry of the mirror mount. As you can see, you have a logo here, you have other parts, and immediately you see the first problem. The first problem is that you have only two parts. However, you would like to have a complete disassembled structure such that you can manipulate with certain objects, such that you can fill in the holes, simplify the geometry, reduce these knobs since we don't need them. They're not essential for our simulation. Let us briefly explain the basic principle for reconstructing the geometry. So what you can see here is a very simple structure consisting of two cylinders, one on top of each other. And the question is how to draw this geometry. Well, our strategy is to define a work plane. So here is the work plane that will contain this circle, and in this work plane we can define a circle. Then the next step is to extrude such a circle. And then the third step is to define another geometry, actually another work plane that will contain this face over here, or this circle. And once we have this work plane, in this work plane we can define a smaller circle, and once we have the smaller circle we can simply extrude it to reproduce this geometry. The same principle we are going to apply to our case. So in our case, the first plane that we are going to extrude, or the first face that we are going to define, or the first cross-section is going to define, it's going to represent this shape, the shape of this region over here. And what we are going to do, we are going to completely ignore this logo. So instead of defining the face that will contain, instead of defining the work plane that will contain this face, we're going to slightly offset such a work plane in order to avoid this engraved company logo that significantly complicates our geometry. In this way, we are going to simplify the geometry and we are going to basically repair our structure such that it can be easily used for meshing. Okay, let us now see how does this strategy work in practice. This is our geometry, and we are going to define a cross-section that will contain the first layer of this geometry. How to do that? Well, if you click on geometry, you have an option work plane. So basically, if you just click on build select, you will see that you have a work plane over here. It's located basically at 0, 0, 0, and it's perpendicular to the basically ZW vector, right? And you can see how does this plane geometry look like. So here is our geometry. However, we are not going to select this option. Instead, we are going to select a plane type that's face parallel. So basically, face parallel work plane is a work plane that is parallel to a certain face of your geometry. In our case, we're going to select this face since this is the base of our geometry. And if we basically click on plane geometry, this will be the cross section. Now, here it's always good practice to deselect these options, because this option, when it's being selected, you can see the whole projection. We don't want that, so always deselect this one. Okay, perfect. Now, you can see over here that we have a logo and we don't want this logo. So what we are going to do, we are going to slightly offset this geometry such that we avoid the logo and that we avoid these annoying holes that are not necessary in the first iteration of defining our geometry. Later on, you can include these holes. So we are going to offset our work plane for, let's say, 0.01 millimeters, and you click on build select, and we are going to select the negative direction, and you can clearly see over here that we are slicing the geometry. And if you click on the cross section, here it is. Here is our cross section. Maybe you cannot see it over here. So the additional step that you need to take is to define a cross section, and you click on build select. So here it is. Here is the region that is your cross section, and this region will be crucial for defining the geometry. We can extrude this region to define the first layer of our geometry. However, we are not going to do this in this COMSOL window. Instead, we are going to save this geometry and we are going to open a new COMSOL window, and we are going to extrude it from a new COMSOL window. That is, in a new COMSOL window, we are going to extrude the geometry from scratch. Okay, so we need to export this geometry, this 2D geometry, to another COMSOL window. How to do that? Well, if you click on, basically on your plane geometry, you can click on export. Okay, and then you can set the file name, and then we are going to choose the folder, and I'm going to call this one layer. Okay, and you click on save, and you click on export. Actually, here you can also verify that you have all the regions. You can also do clear or Control A to select all, but it's selected by default. And by clicking on export, COMSOL will save it in another file. Okay, now the next step is to open a new COMSOL window such that we can basically import and extrude this geometry. Now, what is important here to mention is that if you click basically on the other option here, you can export the complete geometry. However, we don't want that. We don't want that. We want to export this particular geometry. Let's just wait a little bit until our next COMSOL window opens itself. And another thing that we need to figure out, the height of our extrusion. Because you can see over here that the work plane, basically, or our extrusion, should take into account these small supports here. So we need to, the first layer, the height of the first layer will be equal to the height of this edge over here, from here to here. This will be equal, this will be the height. So how to figure out what's this height? Well, we're going to learn another important technique for modeling 3D geometries in COMSOL, and that's how to measure the distances in COMSOL. It's very straightforward. If you click on geometry, and if you click on basically option measure, right, you can select here types of entities that you want to measure. In this case, we can measure the edge. So we can click on this edge, and here it is. Length of the edge is 1.523 millimeters. Okay, so we know that we need to export the first layer for 1.523 or 24 millimeters. So how to do that? Let's do that. So here is our new COMSOL window. What we are going to do, we are going to basically open a new file. Actually, we cannot open a new file. We need to start with a new project. We click on new, we click on model wizard, 3D, we click on solid mechanics, we click on add, although you can select any other option. It's your own choice. We click on study, we click on time dependent, we click on done. Okay, so what we're going to do now, we're going to import the geometry. So we click on geometry, we click on basically we need to select the option to import. We click on import, we click on browse, and here is our geometry. Okay, and we click on import, and here is the error. This is very important. I deliberately did it like this to illustrate you this. So you cannot import 2D geometry into a 3D geometry space. So you need to define, before you do that, let's delete this by pressing delete button, you need to define a work plane. That's the catch. So define a work plane, let this be a 0, 0 work plane, and in this work plane, you can basically, under the plane geometry section, if you double click, you can click on import, right? You click on browse, and then you can select your geometry. And let's click on import. Here it is. Here is our imported geometry. It is a region. It is a region. So we don't need to convert it to region. However, you can try to convert it to a region. It will not hurt you. Okay, so we learned one very important step. The next step is to extrude this geometry for the value that we have measured in our previous code, in our previous COMSOL window. So this is the value. So I'm going to copy and paste this value. And before I paste it, I need to define an extrusion. So if I right click on geometry and I click on extrude, you see COMSOL automatically selects the object in the work plane 1 for extrusion. So that's good. You can also select this option and manually select the face, right? Whatever you want. And let's click on a distance here and then just simply paste the value and click on build select. Okay, here's our first layer. This is our first layer of our geometry. Okay, you can clearly see over here, right, that we are able to accurately reconstruct the first layer. Okay, how to extrude the second layer? Let's see first what is the second layer. Well, the second layer is the section that's defined by the length from here, from this edge to this edge. Since if you closely look in our geometry, between this edge and this edge, the geometry is more or less uniform. There are no details, there are no additional details. So this will be another layer of our extrusion. So how to select this layer? Well, the procedure is the same. What we need to do first? First, we need to define another work plane. Or you can use the same work plane that you have over here and you can change the values. Let's do that. Let's just change the values. So erase this previous selection. We still use the face parallel. And now you have to select the face. In this case, we are going to select this face. Or you can even better use the same face we used before. Or even better, you can use the top face. It's your own choice. Let's stick to this face. Let's click on this face. Okay, this is our geometry. Now, since we need to reproduce the geometry from here to here, and we don't want this to be the base of our geometry, we're going to offset this for a certain amount, let's say for smaller value, let's say for 1 millimeter. Okay, let's see what do we have. You click on plane geometry. Here it is. Here is our geometry. Okay, here is our geometry. However, maybe it would be good idea. Since if you compare this this geometry with the previously defined geometry, let's retrieve it. Okay, I'm going to do this. You'll see that these two geometries are rotated with respect to each other. That's why it's a very good option, or actually very good idea, to keep the same base geometry or the same base face and just to offset your work plane. Okay, so let us do that. Let us offset this for 3 millimeters. Let's see what do we have. Okay, actually it should be minus 3 millimeters. Okay, let's see, are we in the correct region? We are over here. Perfect. This is perfect. Let's see what do we have. Great. Okay, now the next step, we need to save this into a separate file. Let's do that. So we click on plane geometry, we click on export. We choose the name of the file. Let's call it video 2 layer and we click on save. And we click on export. Okay, let us go back to another COMSOL window. Now, what do we need to do? On top of this geometry, we need to export the geometry that we defined previously. How to do that? Well, we need to define a new work plane. So we click on Geometry, we click on Work Plane, okay? We click on Face Parallel, it's going to be on the top, right? And here's our plane geometry, okay? We deselect this option since we don't want to have the projections, okay? Everything is set, right? We are on the top of this face. This will be our geometry. And let's now import here our previously exported geometry. Here it is. Here it is. Okay? We click on import. Okay, now here's the problem that I described previously. You will need to rotate this. You will need to rotate this. How to do that? You need to select basically the center of rotation, but before that you need to align these two regions, or these two circles. How to do that? Well, you can click on plane geometry, you can click on transforms, and you can click on move. Okay, you select this object, and then you can select the displacement. Let's see, let's try in the y direction. What do we need to do? Let's put -1 millimeter, and we click on build. Not bad, not bad. Okay, not bad. Let's see 1.2. What happens? Okay, almost there, almost there. Okay, and then the next step is to rotate this geometry, right? To rotate this geometry. How to do that? Well, you click on plane geometry, transform, and rotate. Okay. Now the center of rotation, right? The center of rotation should be the center of the circle, and you can select it by just clicking here, and let's choose the angle. The angle should be, let's say, 90 degrees. Up, you need to select the region, okay? And here it is. Now, you can see here that basically not everything is aligned perfectly, so you can move these objects a little bit further. You can select here, move, transform, move, and then you can select the value, select the geometry, and let's move this in the y direction for, let's say, 0, 0, 1. Let's see what we have. Okay, not bad, not bad. Let us go back to our plane geometry. Let's see what did we obtain. We click on geometry. Here it is. Okay, click on build all, and let us now extrude the second layer. But before we extrude, we need to go to our original file, and we need to figure out the distance, the extrusion distance, how to figure out this value. We should extrude the geometry from this edge to this edge over here. How to get the values? Well, there are several options. A convenient option is to select in this from the graphics window. You can select points, and then you can just locate 2 points. The first point is here, and the second point is here. And we need the vertical distance, or the distance in the z direction, between this point and this point. How to obtain this distance? How to obtain? Well, again, you click on geometry, you click on measure, and then from this option you want to measure points, right? So I'm going to click here, and I'm going to click here, and here it is. The distance between these points in the z direction is 0.003 millimeters. So I'm going to paste this number, Actually, I'm going to copy this number. Then I'm going to go to my original code. I'm going to click on geometry. I'm going to click on extrude. Okay, and you can see clearly that COMSOL automatically selects work plane 2. And here we're going to put the value, and the value will be the value that we know previously. Okay, here it is. Now, if you click on build all, you can see here that you have an overlay. You have an overlay. You can eliminate this overlay by going back to our original geometry, move option, and then you can slightly move your base in one direction. Let's see what happens, or the another direction. This is not the proper value, but you can tune. You can tune by doing this. You can basically tune your, you can eliminate this overlay, right? I decrease this overlay a little bit. You can do it. You can even play with these parameters. You can choose this value, and by doing this step by step, you can completely eliminate this overlay. Now, I'm not going to reconstruct the whole geometry in interest of time. You can do it by yourself. However, what is important to mention here is that when you mesh such an object, let's run the simple meshing, you will most likely obtain the error. Let's see, maybe not. Yes, we are obtaining the error here. So what we are seeing here is that we are not able to generate a mesh for these domains, right? There are several reasons for that. Intersecting face elements, etc. So you can eliminate these type of errors by defining a union. So once you extrude the whole geometry, you need to define a union. You click on geometry, you click on conversions, or actually not on conversions, you click on, let's see, this option, booleans and partitions, you click on union, and then you click on control all, and you click on build select. Now you have a new union. Let's see the meshing once more. Most likely we'll still obtain an error. Let's see. Okay, so there's still an error over here. However, usually a good step is to defeature and repair your geometry. You can click on repair, and basically you can select all, right? You can play here with options, simplify curves and surfaces, and you do build select. Okay, so by doing this, by playing a little bit with the geometry shaping and with the repairing options, you can simplify your geometry, and you can repair meshing. In the meshing section, you can repair your mesh. Okay, so the final step in recreating our geometry and in doing this analysis is basically to make sure that we can properly mesh. We can see that the repair option is still not working properly, since if I mesh my object, I have these errors. So how to eliminate these errors? These errors often appear when you basically reconstruct the geometry with a lot of details. So these errors can come from the fact that some faces are narrow and you have an overlay, or you basically, some elements are too small, some holes are too small. Of course, you can play with the mesh, but a quick and dirty solution is to click on geometry, you click on virtual operation, you click on remove detail. And here you can say that basically you want to remove vertices with continuous tangent, short edges, small faces. Right, you're removing all the small details, and you click build select. Okay, here it is. This is the summary, this is the report of the quantities that have been removed. You have 14 ignore vertices, 3 collapsed edges, 6 collapsed faces, and 10 regions, right? Let's now repeat the meshing step. We click on build all. And here it is. We are able to mesh our geometry. We only have a few warnings. However, you can improve basically, you can basically eliminate these warnings by additionally meshing your geometry at certain regions. However, you will still be able to compute some initial solutions. So your compiler, COMSOL compiler, and COMSOL engine, the solution engine, will still work. Okay, that will be all for today. Thank you very much for your attention and have a nice day.